Welcome to this video on classifying trees. Today we're going to explore how we can classify trees by analyzing leaves. First, let's take a step back and review what we know about the parts of a tree. So a tree has these main parts. Of course, we all know what the roots are. They're very important for helping to keep the tree firmly in the ground. Now, this diagram is a little unrealistic because in reality, the root ball underground is usually pretty much the same size as the part of the tree that has all the leaves on it above ground. And we'll learn the word for that part very soon. Of course, we know the important woody trunk of a tree, having a single self-supporting wooden trunk, is one of the characteristics that makes a tree a tree. If it doesn't have that, it's not a tree. We also have branches, and these are the parts that branch out from the trunk, hence the word branches. The next part that we have is our twigs, and the twigs are the things that branch out from the branches. So trunk, branches, twigs. And last but not least, we have our leaves. You guys all know what leaves are. There's one other section of a tree that is important to know, and that is the crown. That's this upper part of the tree where all the branches and leaves are. And if you think about it, that word crown makes sense because it's like the top. And where do you put a crown? On top of your head. Let's see what the shapes of different trees can tell us about the trees. So this is a silhouette of a spruce tree, and it's shaped very much like an oval. We call this shape columnar. And you can see the word column right in that word columnar. So columnar means like a column, and a column is something that is long and thin and vertical. This next shape is one that we're all familiar with. It's that, pardon me, famous Christmas tree shape that looks like a triangle, and this happens to be a pine tree in this example, and we call that shape pyramidal. And you can see the word pyramid in it, and it does have that triangular shape which we associate with pyramids. And I'll close the camera so we can see this last one really well. This apple tree here is shaped like a circle, and we call this shape round. Pretty straightforward. Now, what can the branching patterns of trees tell us about what different kind of tree it might be? Well, tree branches usually grow in one of three ways, and those ways are, it's represented by these stick person characters here, outward. So you see our stick person is holding their arms straight out. So that's outward branch patterns. Sometimes the branches aim sort of out and down, and we call that downward branching pattern. And often the branches are pointing right up, like this stick person with their arms up in the air. And that, of course, is called upward. Let's take a look at the different parts of a leaf, because scientists use this information to help them find out really important details about what species we might be looking at. And here you go. Scientists begin by analyzing leaf specimens and identifying each part. We start with the apex. That's the very tippy top of the leaf, and it might be pointed, but it might not. But the word apex means the same as top. And then the outer part of the leaf, the very edge, is called the margin. So we might call that the edge sometimes, but the official scientific word is margin. And margin is a word that means edge, so it makes sense as well. This part that is raised up in the very center of the leaf, kind of like a spine, well, its official name is midrib. And I like the fact that it has mid right in the middle of the, or right at the beginning of the word, because it reminds me that it's in the middle of the leaf. And then you're probably not surprised to know that these things that look like veins are called veins. Easy. The very bottom of the leaf is called the base. That makes sense too. And then this little part that we might be tempted to call a stem is actually called a petiole, because it doesn't have the same job as a stem does on a plant, because a stem attaches to the roots and the petiole does not attach the roots, it attaches to the twig. So we have to be precise in our vocabulary. And finally, the whole leaf, the whole thing, the whole big flat part of the leaf there, that is called the blade of the leaf. All right, so the next step that scientists take is looking at leaf shapes to see what they can learn to help them identify what species of tree they might be looking at. Let's start with this one on the left, this long skinny one. This type of leaf shape is called linear, and you can see the word line right in the word linear, and that's because linear means it's in a line shape. So linear leaves are long and thin, like a line, and they have a pointy end or a pointy apex. Oblong leaves are long and thin as well. That's what the word oblong means, but they don't have a pointy end. So that's the difference between these two. A linear leaf has a pointy end, an oblong leaf does not have a pointy end. This next shape here is called oval. It's basically an oval shape, like a circle that's been pressed in at the sides. And ovate leaves are like oval leaves, but they have a pointy end. So you can see the words are quite related. Ovate actually comes from oval. It means kind of like an oval, but because it has a pointy end, it's not actually an oval. Here are some more shapes. Cordate leaves are shaped like hearts. Now, I'm going to share a little something with you. This word here, or this root here, cor, comes from a Latin word. And I happen to know a word in French that also comes from that Latin word. And in French, it's spelled with a lot of vowels. French likes to put a lot of vowels together to make some of the sounds in their language. So this word here spells cœur, which means heart. And cœur, you can see, kind of sounds like core. And we can see that this leaf actually does have a heart shape. So cordate means like a heart, and it's a leaf that is shaped like a heart. Deltoid leaves, on the other hand, are shaped like triangles. You have a muscle in your body on your back called the deltoid, and it's shaped like a triangle as well. That's because the word deltoid comes from the Greek word for shaped like a triangle. And these last nice round leaves are called orbicular. And you may recognize the word orb inside orbicular, which means circle or sphere. So an orb is a circle shape. Orbicular leaves are round. All right, a couple of more leaf shapes here. First, we have our lobed leaves. Lobed leaves have wavy sides. They actually have these lobes sticking out from them. So these little rounded bits that stick out are called lobes. So the leaves that have lobes are called lobed leaves. Straightforward. Now let's look at needle shapes. If you take a needle from a conifer and don't look at it sideways, but look at it straight on from the end, you'll see that some of them look like they have four sides. They look square when you look at them. They are called four-sided needles. Other ones are flat, and they are called two-sided needles because, of course, they only have those two sides instead of 1, 2, 3, 4. Now, we're going to look at leaf margins, or the edges of the leaves. Smooth edges are flat and not spiky. I don't think I need to spend too much time explaining that. It's pretty self-explanatory. Fine-toothed edges have small spikes or teeth along the edges. So the margins of some leaves have very tiny little pointy teeth along the edges of them, and we call those fine-toothed edges. Other leaves have bigger teeth or spikes along the edges, and we call these leaves serrated because they are serrated. That's what the word serrated means. So if you've ever used a bread knife to cut bread and you know it has lots of little points on the side, bread knives are serrated. Saws for cutting wood are also serrated. That word means it has teeth or pointy teeth along the edge. Now, important to know that serrated edges have small teeth, but they're bigger than the tiny teeth on the fine-toothed leaves. And the final kind of margin that we're going to look at here is called scalloped. And scallop just means anything that's wavy. And you'll know if you've ever seen a scallop in the ocean, and that's what this is supposed to look like, where its shell closes, it meets in a wavy edge like that. That's where we get the word scallop from. Now let's look at how the leaves grow on the tree. Simple leaves are attached to the twig, pardon me, singly, so one leaf at a time. Compound leaves are attached to the twig in groups. So this here is the twig, and here's the petiole joining this group of 7 leaves to the twig. Different kinds of leaf arrangements are opposite leaves. So opposite leaves grow right across from each other on opposite sides of the stem. So they are kind of attaching at the same exact point, but they are opposite to each other. Alternate leaves grow one after the other, or they alternate on opposite sides. So one, then up a bit, and then on the other side, then up a bit, back to the left side, up a bit, off to the right side, alternating. And the last kind is a whorl leaf, which grows in a ring around the stem, kind of like a spiral as it goes higher and higher. Needle arrangements can tell us a lot about coniferous trees. So single needles grow alone out of a twig. You can see here, one at a time. Bundles of 2 needles grow in pairs. 1, 2. And they're coming out here together in a pair. Bundles of 5 needles grow together in groups of 5. So we have single, bundles of 2, bundles of 5. And then we actually have bunches of more than 5. So if you see a bunch of needles and there's more than 5 of them in the bunch, then it's considered a bunch of more than 5. And the last kind of needle we have are scales. And they actually are not pointy and long, but they're flat and thick, and they really look like scales. So you'll have no trouble identifying those. So how does all this information help us classify trees? Well, that is the subject of your next assignment, Science 9.2, where you're going to go through all of the steps of using a key to help you identify different leaves and tell which tree those leaves came from.